Computers are everywhere today. From smartphones to self-driving cars, the digital world runs on computing power. But have you ever stopped to wonder where it all started? What was the first computer ever built, and how did it shape the technology we rely on today? The story of the world's first computer is a journey through time, filled with brilliant minds, unexpected discoveries, and machines that changed history forever. Stick around, because by the end of this video, you'll see how a few groundbreaking ideas led to the modern digital revolution. The ancient beginnings, the Antikythera mechanism. Long before silicon chips and binary code, ancient civilizations experimented with mechanical computing. The earliest known example of a computing device is the Antikythera mechanism, an ancient Greek artifact discovered in a shipwreck off the coast of Greece in 1901. Dating back to around 100 BCE, this incredible machine was designed to predict astronomical positions and eclipses. It consisted of dozens of interlocking gears and was surprisingly sophisticated for its time. Some researchers even call it the world's first analog computer. But despite its brilliance, the knowledge required to build such a device was lost for centuries. It wasn't until the 20th century that scientists truly understood its purpose. Imagine if ancient Greece had continued developing this technology, how different would our world be today? Charles Babbage and the birth of the analytical engine. Fast forward to the 19th century, and we meet a man whose ideas were centuries ahead of his time. Charles Babbage, known as the father of the computer, Babbage designed a machine in the 1830s called the analytical engine. This wasn't just a simple calculator. It had all the core features of a modern computer, an arithmetic unit, memory storage, and even a way to receive instructions through punch cards. It was a revolutionary idea, but there was one problem. Technology at the time simply wasn't advanced enough to build it. Babbage's vision remained just that, a vision. However, his work laid the foundation for everything that followed. And here's where things get even more interesting. A woman named Ada Lovelace worked closely with Babbage and wrote what is now considered the world's first computer program. That's right, the first programmer in history was a woman. If Babbage's machine had been built, we could have had computers over a century earlier. The rise of electromechanical computers, the Zeus Z3. While Babbage's analytical engine remained unfinished, progress didn't stop. In the 1940s, a German engineer named Konrad Zuse developed the Z3, which is widely considered the first programmable computer. Unlike its mechanical predecessors, the Z3 used electromechanical switches to perform calculations. It could handle complex mathematical problems at a speed that was revolutionary for its time. But here's the twist. The Z3 was destroyed during World War II, and much of Zuse's work was overshadowed by wartime secrecy. Imagine spending years building something groundbreaking, only to see it wiped out in an instant. But Zuse didn't give up. He went on to create more advanced computing machines after the war. Though his contributions were lesser known at the time, today he is recognized as a pioneer who helped bridge the gap between mechanical and digital computing. The ENIAC, the first general-purpose digital computer. The real turning point in computing history came in the 1940s with the development of the electronic numerical integrator and computer. Built by John Presper Eckert and John Mopsley in the United States, the electronic numerical integrator and computer was the world's first fully electronic general-purpose computer. Unlike earlier machines, it didn't rely on mechanical parts. It used vacuum tubes, which made it significantly faster. An electronic numerical integrator and computer could perform thousands of calculations per second, which was mind-blowing at the time. But there was one catch: it was massive. The electronic numerical integrator and computer weighed 30 tons, took up 1,800 square feet, and consumed 150 kilowatts of power. Just imagine, today, a tiny smartphone is millions of times more powerful than this gigantic machine. Electronic numerical integrator and computer was originally designed to calculate artillery trajectories during World War II, but its success paved the way for future computers. It showed the world that electronic computing was the future. The transition to stored program computers, the Manchester baby. One major limitation of the electronic numerical integrator and computer was that reprogramming it was extremely difficult. Every time you wanted to change what it did, you had to physically rewire the machine. That all changed in 1948 with the creation of the Manchester baby, the first computer that used a stored program. This meant that instead of rewiring hardware, you could simply change the instructions stored in its memory. This was a game changer. The Manchester baby was built by Frederick Williams, Tom Kilburn, and Geoff Tootle at the University of Manchester. And though it was much smaller than the ENIAC, it introduced a concept that would define modern computing. Without this breakthrough, we wouldn't have modern software, apps, or even video games. Imagine having to physically rewire your computer every time you wanted to send an email. Sounds exhausting, right? That's exactly what early programmers had to deal with before stored programs became the norm. The dawn of the commercial computer era, ENIAC. The next big step came with the Universal Automatic Computer I, the first commercial computer. Developed in 1951 by Eckert and Moxley, the same team behind ENIAC. ENIAC was designed for businesses and government agencies rather than just scientific calculations. One of its most famous moments came in the 1952 U.S. presidential election, when it correctly predicted Dwight Eisenhower's landslide victory based on a small sample of votes. People were shocked. How could a machine predict an election better than human experts? This moment demonstrated the power of computing and changed the public's perception of what computers could do. Today, data analytics and predictive modeling are used everywhere, from politics to sports betting, and it all started with the ENIAC, the modern computer revolution and beyond. By the 1950s and 60s, computers were rapidly evolving. The invention of the transistor in 1947 replaced bulky vacuum tubes, making computers smaller, faster, and more efficient. Then, in the 1970s, the development of microprocessors led to the rise of personal computers. Companies like IBM, Apple, and Microsoft took computing from massive, room-sized machines to desktops, laptops, and eventually smartphones. Today, computers are everywhere, from the phone in your pocket to the artificial intelligence systems that power self-driving cars. And to think, it all started with mechanical gears and vacuum tubes. The invention of the internet, connecting computers worldwide. While individual computers were becoming more powerful, one of the most revolutionary breakthroughs came when scientists figured out how to connect them. This led to the invention of the internet, which transformed computing forever. The origins of the internet date back to the ARPANET in the late 1960s, a network developed by the U.S. Department of Defense to allow computers to communicate over long distances. At the time, no one could have predicted just how massive this idea would become. In the early days, only a few universities and research institutions were connected, but by the 1990s, the World Wide Web made the internet accessible to the public. Suddenly, computers weren't just powerful tools for individuals, they became gateways to unlimited information, communication, and entertainment. Today, everything from social media to cloud computing relies on the internet, and it's hard to imagine a world without it. Just think, if the first computers were built in isolation, the internet transformed them into an unstoppable global force. What's next? Maybe computers will soon connect directly to our brains. The future of computing. So, what's next? We've gone from ancient gears to massive mainframes to tiny chips, but the journey isn't over. Quantum computers are already being developed, promising computing power beyond anything we've seen before. Artificial intelligence is pushing the limits of what computers can do, and the future is more exciting than ever. Who knows? In a few decades, people might look back at today's technology the way we look at the ENIAC, huge, slow, and outdated. If you found this journey through computing history fascinating, don't forget to like, subscribe, and hit that notification bell for more amazing content. What do you think the future of computing holds? Let us know in the comments.